video, we're going to go ahead and go over the sample distributions. We're really going to look at percentiles and percentages, just to build on what we've done with our sampling distributions of our means and proportions. Okay, so let's look at an example. Based on data from the National Health Survey, women between the ages of 18 and 24 have an average systolic blood pressure of 114.8 with a standard deviation of 13.1. Systolic blood pressure for women between the ages of 18 to 24 follow a normal distribution. So that means that we can actually use our normal table over here on the right. Okay, so part A. If a woman is randomly selected, what is the probability that her blood pressure is above 120? So we're really looking at the probability that X, now notice I use X here because it says if a woman is randomly selected. So we don't have a sample size greater than 1, so we're just going to use X. So to use our standard normal table over here on the right, we need to convert this data to a z-score. So we'll revisit the z-score formula. It's our data minus our mean over standard deviation. We'll plug everything in. So we have our data of 120, which is what we were given in part A. We have our mean, which is mu, given in the original problem, 114.8. And we've got our standard deviation of 13.1. So crunching that number in the calculator, depending on the question, we may want to round to 3 or 4 decimals. I always round to 4 and just be careful. And then when I go ahead and look over on the z-score chart, I can round appropriately to what I need over there. Okay, so let's go ahead and rewrite. Instead of our probability of X being greater than 120, that's going to be equivalent to the probability that our z-score is greater than 0.3969. So we'll go ahead and draw our normal curve and mark our z-score. I've marked it as 0.40 because the z-score table on the right only goes to 2 decimals for the z-score. If you were using a TI calculator or Excel, something like that, you could use this full 4 decimals. But our z-score table is pretty limited to 2 decimals, so we'll just go ahead and mark that. Okay, so now we want to look at this. Notice that we've got tail and area here. So when we look over on our z-score chart, remember tail and area, we are going to look for a z-score and then we're going to have to subtract that from 1/2 or 0.5 because that's the whole thing. So looking for 0.40, so we go 0.40, and we get that area right there, which is 0.01554. So we'll go back over here and we'll take 0.5, so it's the entire half right side, and then we want to subtract off that little area that we found from the z-score that goes from 0 to our z-score, which we notice is not shaded here, and then we put in our area that we found from our table. So that gives us 0.3446. Okay, let's look at another example. Let me go ahead and erase what we did for the last one. Okay, so based on the data, we still have our blood pressure of 114.8 with a standard deviation of 13.1. This one asks, a doctor wishes to determine the 80th percentile of blood pressure readings. What would the blood pressure reading be? So this one's a little bit different. This asks us to actually find the blood pressure reading. And in the last question, we were given that blood pressure reading of 120, and then we found that area. So remember, the 80th percentile means that 80% of the area is below the data point. And of course, we're going to be using the decimal because everything's in decimals when we start putting this in a formula. So let me go ahead and draw a picture for this. So we've got our area here. 80% is quite large, so we want to go more than half, which means it's somewhere on the right. So our whole goal right now is just to find the z-score, because we know that this area is 80% or 0.8, but we need to find that z-score. So we're going to go a little bit backwards here. So I'm going to look for 0.8 in the body of this table. So this is going to be a little bit more difficult. So 0.8. Okay, so we notice that on here, it looks like everything goes up to 0.5. So we have to be a little bit tricky. So notice that this gives us only that area between 0 and our z-score. And we have this whole entire half plus that little shaded area. So let me go back here. So we need this whole entire half plus from 0 all the way to our z-score. So really, if this is half, if we want this whole thing to be 80%, we're really only looking for 30% or 0.30. Okay, so let's go back over here. Now we're going to look for 0.30. So it looks like these guys are the closest to 0.30, and then between the two, it looks like this one, the 0.2995, is closer to 0.30. So let me go ahead and erase that, and we will just circle that guy. Okay, so to trace back to our z-score, we go back here, and we get 0.8, 4. Okay, so we've got our z-score of 0.84. So now, just revisiting what the question asked, it says, what would the blood pressure reading be? So remember, we want the data. So we went backwards from the area, we traced it back to the z-score, and now we actually want the data point. So let me put my z-score formula there. We're going to fill in everything that we know. So we found the z-score based on that area of 0.80, which was from the percentile. We don't know our data, so I'm going to leave that X. We know our mean and our standard deviation. So we want to clear the fractions. We want to multiply both sides by 13.1. So we've got our 0.84 times 13.1 equals X minus 114.8. That gives us 11.004, and that still equals X minus 114.8. And then we'll add that 114.8 to both sides, and we get our data point of 125.804. And again, depending on how the question asks, it didn't really give us to a decimal point, so you can leave it 1, 2, 3 decimals, whatever you feel like. Okay, so let's go ahead and look at another example. Let me go ahead and get rid of all of our work here. Okay. So this one gives us the same thing. We've got our mean blood pressure of 114.8, still have our standard deviation of 13.1. This one says a doctor wishes to determine the 80th percentile of blood pressure readings from a sample of 40 women. What would the blood pressure reading be? Okay, so this one says from a sample. So we're going to do similar steps, but then we're going to have to be careful with this sample. The last one didn't have that. So we still want to revisit that our 80th percentile gives us 80% of area below the data point. So we'll go ahead and draw that same picture here. And we still have that area. We actually already looked up that 0.3, so we'll go right to our z-score of 0.84. So nothing here is different. So the sample size is not going to affect the z-score here. It is going to affect our data when we solve. So I'll put up our z-score formula. And then notice here the difference. We have 0.84 times equals X minus our mean over our standard deviation. But remember, for a sample, we have to adjust that standard deviation by dividing by the square root of n. So what we're going to do is we're going to multiply by the reciprocal this time to clear those fractions. So we've got 0.84. The reciprocal is square root of 40 over 13.1, and that now equals X minus 114.8. Okay, so putting that in our calculator, we've got 0.4055 equals X minus 114.8, and then adding that 114.8 to both sides gives us a cutoff of 115.21. Okay, last one here. A doctor wishes to determine the middle 95% of blood pressure readings. What would the cutoff readings be? So again, this one doesn't give a sample size, so we don't have any of that square root of n again in this problem. So the middle 95% means that we have 47.5% below the mean and 47.5% above the mean. So we're just splitting it right in half down the middle. Let me draw a picture. So we have exactly symmetric area. This whole thing is 95% or 0.95. And if I were to draw a line right up the middle here, we'd have 0.475 over here and 0.475 over here. Okay, so looking here, we get a z-score of 1.96 and negative 1.96. Let's go to our z-score chart. Let me show you how I got that. So I'm looking for that 0.475 and looking here. Oh, found it. There we go. So it's 0.475. I found it exactly, so now I have to figure out which one's closest. Trace it back. And we notice that we've got 1.96, and these are always positive, but because it's symmetric, that's how I got that negative 1.96. Okay, so let's go ahead and find the z-scores plural. So we're going to have two different ones. We can't just do it for the positive and then negate whatever answer we get, so we have to actually do them separate. So let me go ahead and do z1. So in this case, we're going to use the negative 1.96. We've got our data, which we don't know, minus the mean over standard deviation. Notice I don't have a divide by square root of n because I don't have a sample size, so I'm going to leave that out. I'm going to multiply both sides by 13.1 to clear those fractions, and then add that 114.8, and we get our first cutoff. So this, because that was on the negative z-score side, this would be our negative cutoff, or our lower cutoff. It's obviously not negative, but this would be our lower cutoff. And now we need to redo this for our second z-score of 1.96. This will be our upper cutoff. So I'm going to plug in the 1.96, do the same thing. I'm going to clear fractions, multiply that out, add the 114.8, and we get that upper cutoff. So what would the cutoff readings be? Well, on the lower end, we'd have a blood pressure of 89.124, and on the upper end, we'd have a blood pressure reading of 140.476.